What's up, scholars? Welcome back. I'm Ms. Akin,
And I'm Lisa.
and today we
And
are
today,
talking about
parallel and perpendicular lines. All right, so today we're gonna do parallel lines versus perpendicular lines. And if you guys remember, we've actually already talked about these. So parallel lines are just lines that never meet and go forever and ever both directions due to the fact that they're lines. And then our perpendicular lines are lines that meet at a 90-degree angle. So they make those 90-degree angles where they meet. And in our lesson today, we're actually going to identify these parallel and perpendicular lines from their equations. So we've already talked about what they are. So now let's see how we can derive them from equations.
what's the important part of the equation we're going to look for, Lisa?
So we're going to see their property at the end or their slope at the end.
Yeah. What do you know about the slope of parallel lines?
So I know that the slope of parallel lines will actually be the same. So
What do you
they're
know
going to have
about
the
the
same slope.
slope of perpendicular lines?
And the slope of perpendicular lines will be opposite reciprocal slopes.
Opposite reciprocal. Okay, so for example, if the slope of one of the lines was 3/2, what would be the opposite reciprocal to 3/2?
It'd be -2/3.
Or what if we had -5? What would be the opposite reciprocal slope to -5?
It'd be 1/5 due to the fact that we always have to say that there's an imaginary 1 under our whole numbers.
Oh, cool. All right, let's put some examples of equations up on the board and see if we can decide if they are parallel or perpendicular.
So here we have 3 examples, and we're actually going to see if these are parallel, perpendicular, or neither from their slopes. But before we actually get into that, what do we need to do, Ms. Atkin, in order to find the slopes of these 3 lines?
Well, one of these guys is looking good. I know the slope of line 3 is -4/3, because it's the number in front of x. Because this one is in slope-intercept form, but that's not the case for line 1 and line 2, so we're going to have to rearrange both of these. So let's look at line 1 first and try to get it into sloppy intercept so we can see what the slope is. What would we do first here, Lisa?
Well, I think the first thing I would do is actually subtract 6x from the left side and then subtract it from the right side to begin to get our y by itself. And then we would want to divide the left side by -8 and the entire right side by -8 in order to get that y on its own. And we would get y equals 6/8, which is reduced to 3/4 x plus 1/2.
So what is the slope of line 1, Lisa?
3/4, because that's your y, or that's your m, or what is right behind your x. So
Yeah.
the slope of line 1 is 3/4.
So now let's check out line 2.
We're going to go ahead and do the exact same thing, but we actually have more done to this one. So all we're going to need to do is divide the -4 on the left side, do the same to the right side, and we get y equals -3/4 x minus 7/4. So our slope in line 2 is -3/4. So we have our 3 slopes ready. So now we need to decide which lines are parallel, which are perpendicular, and which are neither.
All right, let me put the little list up here. Sorry, it's getting a little disorganized. So we'll have our parallel lines, our perpendicular, and then let's see if anybody's neither. Do you see a pair of lines that are parallel, Lisa?
I don't see any that are parallel due to the fact there's no slope that is exactly the same.
Ah, gotcha. So nobody's parallel. Cool.
Nobody is parallel.
Do you see anybody that's perpendicular?
If we look for perpendicular, so I need to look for the opposite reciprocal slope. So I do see that line 1 is 3/4, and then I see that line 3 is -4/3. So I think those are perpendicular lines.
Awesome.
And then finally, some that are neither would just be the rest, as I don't see any more opposite reciprocals or same slopes.
Yeah, so like line 2 and line 3, those would be neither, right?
Neither. Those would be neither, as they're not opposite reciprocals or the same.
And how about line 2 and line 1?
Those would be neither as well. They were almost parallel, but one of them is negative, so it doesn't work out.
That is true. Nicely done, everybody.
Next up in our lesson, we're going to write equations of parallel and perpendicular lines. So our example that we are given says, consider the line y equals 6x minus 3. So our first question says here, find the equation of the line parallel, so that means we're going to have the same slope, parallel to that line, which is the line we're given, that goes through the coordinates -7, 5. So the first thing I'm looking at, okay, we have parallel lines, so we're going to have the same slope, but in order for us to find the equation, we're going to need that y-intercept, which is our b. Because if we remember, this line is actually y equals mx plus b, and that b is our y-intercept, which we need to finally finish off that equation. So the first thing I would do when solving for this is say, okay, I have my y coordinate, so we can just go ahead and plug that in for part A. So we would put 5 in place of our y. We would then equal that to 6, so we keep the same slope due to the fact that they're parallel, and we plug in our x, so -7, and then at the end just say plus b, since we need that last part to finish off our equation. So we just solve this. We would then add our 42 to get b by itself, and our b-intercept would be 47. So what is the equation of that line? It would be y equals, because remember we're solving for that line, y equals 6x plus 47. 6 being the same slope as the first line due to the fact that they're parallel, and 47 being that y-intercept.
Beautiful.
For our second question, we're given the same line, y equals 6x minus 3. Remember, this is actually y equals mx plus b. And our question starts off by saying, find the equation of the line perpendicular to, which means opposite reciprocal slope, so we're not going to use the same slope, to this line that goes through the points -7 and 5. Remember, your -7 is your x and your 5 is your y. So the first thing I would do is say, okay, my slope here is not going to be the same. So for your m, you're actually going to put in place -1/6. Why is that? Opposite reciprocal to 6. So let's go ahead and do the same thing we did last time. Plug that y in for our y, which is 5, equals the negative reciprocal slope, -1/6. Plug in your x, which is -7. And finally solve for that plus b, as it's a crucial part to finding the equation. So go ahead and solve this problem. We will then get 5 is equal to 7/6 plus b.
7/6. What is that as a decimal? That's not a very nice one. Not a very nice one at all. Let's see.
It's a messy one.
Let's make some common denominators. So I'll multiply this guy by 5 to get 30. Is that what I want? What do we want here? What are we gonna do? If I multiply that to be 30, then I need to multiply this by 30. Yeah, so 30. So it'll be 150/30 is 35/30 plus
There
b.
you go.
There we go. Just seems so big because it is so big. So 150/30 minus 35/30 equals b. That
Equal
was
to b.
Yeah. So we get 115/30 is b. I have a feeling we can reduce that.
I think we can as well.
5 definitely goes into both of these. So we could do 115 divided by 5 and get 23/30 divided by 5 is 6. So that's as good as we're going to do there.
So our answer for B is 23/6. And remember, guys, you aren't done yet. Let's go ahead and write down that equation. So you're going to get y equals negative reciprocal slope 1 over 6x plus 23 over 6. So this is the equation of the line that is perpendicular to y equals 6x minus 3.
Beautiful. Go.
For the last part of our lesson today, we're going to identify parallel and perpendicular lines from the coordinates. So the first thing that we're given are 3 lines, and we're given the points, not the equations. And what we're going to want to do first is find the slopes of these coordinates in order to identify whether they're parallel or perpendicular to each other. So when we find the slope, you do y2 minus y1 over x2 minus x1, and that will equal your m, or your slope. So let's go ahead and do this for every line. So just go ahead and label the top of those lines with which one it is, 3 being x1, 0 being y1, and 6 being x2, 2 being y2. So go ahead and plug those numbers into your equation so you can go ahead and solve for the slope of line 1.
We'll have 2 minus 0 over 6 minus 3. Let's get just 2 over 3. Cool.
So we'll want to go ahead and do the same thing for our second and third line, Ms. Atkin. Always remember, it's super helpful to label things. Just labeling makes it much easier for Ms. Atkin to plug these numbers in.
Lisa, what do I do if I have 2 negatives next to each other?
So you can actually go ahead and add them, Ms. Atkin, because those negatives cancel each other out. So you'll do 4 plus 2. So you'll get 6 over 4, and you can actually reduce that.
So what do we get?
2, so we would get 3 over 2.
Oh man, these guys were almost perpendicular, weren't they?
Almost.
Close.
And then when we do the same thing to their third line, label what they are, plug those numbers back into your equation. And for this one, we will get negative 3 over negative 2. So we have our 3 slopes for these lines.
What if there's 2 negatives? What can I do with the 2 negatives?
You can actually cancel those negatives out.
So
they cancel each other out, and they just become positive. So the slope for line 3 is actually 3 over 2.
All right, so let's look at some comparisons of some pairs. Line 1 and line 2, are they parallel, perpendicular, or neither?
It looks like they're neither. They were almost perpendicular, but they're not opposite. They're both positive, so no, 1 and 2 are neither.
How about 1 and 3?
1 and 3, they're also neither, as they're not parallel nor perpendicular.
How about 2 and 3?
And it looks like 2 and 3 are actually parallel due to the fact that they have the exact same slope.
Cool. All right, if I was looking for the perpendicular slope to 2/3, what would that be?
So a perpendicular slope of 2/3 would be negative 3 over 2. Remember, it's opposite, so it's negative, and reciprocal, so you just flip that fraction or slope.
Cool.
Let's go ahead and do our final review for parallel lines and perpendicular lines. Remember, parallel lines are lines that never cross. Perpendicular lines come to meet at a 90-degree angle. The slope of parallel lines will actually be the same, while the slope of perpendicular lines will be opposite reciprocals of one another. When you're trying to find the slopes and see if they're parallel, perpendicular, or neither, remember that you need to put them in slope-intercept form, which is y equals mx plus b. Always want y by itself on the left side. Remember, same slope, parallel, opposite reciprocal means perpendicular. For the next part of our lesson, we talked about writing the equations of parallel and perpendicular lines. When you want to find that equation and you're given the same, if it is said that they are parallel, remember to use the same slope. And we're going to want to solve for our plus b in this part, as it's a crucial part to that equation. Once you solve for b, keep that same slope since they're parallel, plug in your b at the end, and you keep it in slope-intercept form. And then for your last one, same idea, just perpendicular. So do your opposite reciprocal slope, plug in that b at the end, and remember to write it in y equals mx plus b. And last but not least, we talked about identifying parallel and perpendicular lines from their coordinates. Remember that when you're given coordinates, to find the slopes, you're going to do y2 minus y1 over x2 minus x1 is equal to m. Remember to label those coordinates, x1, y1, etc. And once you plug those in for your equation, solve for your slopes. And once again, same slopes mean parallel, opposite reciprocals mean perpendicular.
Nicely done, scholars. You made it through parallel versus perpendicular lines, a death match to the end. I've been Miss Atkin.
And I've been Lisa. Thank you guys for watching us today.
Keep on that hustle. See you next time.